Hello there, and welcome to Lab 2 of Physics 2. My name is Noah Geiger, and let's just hop right into it. So the purpose of this lab is instead of treating the tapes as a point charge, we're going to be treating them as a line of charges. The reasoning for this is we're trying to make a model that's more accurate to what's actually happening, since we know there's charges distributed throughout the tape. So some highlighted results are the magnitude of our charge of one piece of tape is 1.8 times 10 to the negative e coulombs. And as we'll see, it's about a 50% increase from last experiment. Lab 2 model. So the model will look very similar to Lab 1. This will be almost entirely a coding thing since we are going to use the data from Lab 1. Again, the difference is instead of treating it as point charges, we're going to treat it as a line of charges. So we're going to make the same assumptions as we did in Lab 1. We're going to neglect air resistance, and we're going to assume the charge is uniformly distributed because we have no way of measuring the changes in charge throughout the tape. So that's why we have to assume it's equally distributed. Some relevant concepts, same thing as Lab 1, except a new one, and that's going to be in the end. So first one, we got Coulomb's law. That's going to help uh, tell us the force of the charge. Second one, we got Newton's second law. That's going to help identify the charges on the tape when we use it in tangent with Coulomb's law. And then the third one, which will be used more in this experiment, is the distribution of charges, which basically says your net electric field equals the sum of all your electric fields. And that's going to be useful because uh, since we have multiple charges, we're going to have numerous electric fields, and we're going to have to add them all together to get the net field. So again, model, same thing as Lab 1, same dimensions, same mass. The only thing different is we're going to have some experiment with coding. And just to remind you of the results for Lab 1, magnitude of electric force was 1.8 times 10 to the negative 5 coulombs. Magnitude of the gravitational force was 1.6 times 10 to the negative 3. Um, all these numbers here are just, again, from our Lab 1. They're not necessarily relevant to this lab. So let's move on. So coding. So said the main differences was coding. So let me show you. So as we see here, uh, our E is going to consist of the charge times gravity over um, R times R hat. Um, and this is just going to help us get the electric field at each point. That's kind of a bad way of explaining it, but this is going to basically what this is saying is take it at each point. And if we move down here into these areas, what is this is doing is this is basically adding up all the charges together so that we could get E net, and we're gonna run the program here. And you can kind of see in the model, uh, all the charges are being added to one another, and this is going to help us give our results. Magnitude of the electric force is going to be 5.8 times 10 to the negative 4. Magnitude of gravitational force is going to be the same, which is what we expected. The magnitude on charge of one piece of tape is 1.8 times 10 to the negative 8th. So back to the presentation. Discussion results. So the magnitude of the magnitude on one piece of tape has increased about 50%, while the magnitude of the electric force uh has increased by nearly 400%, so that's 4 times. So some sources of error, um, some could be similar to Lab 1, it's just air resistance and electrons transferring from the tape to my hands. Since this isn't a perfect experiment, electrons do transfer. So we're going to go to our what if. So what if we had modeled as a single point, compare the estimated charge to give what your experiment data to produce a point charge model to the value you got with your line charge. So yeah, we're just comparing the two. Lab 1, we got 1.8 times 10 to the fifth, negative fifth, and we got 5.86 times 10 to the fifth. Why are these different? They probably differ because we're taking a lot more in consideration to Lab 2, And since we're adding multiple points, we're kind of getting a more accurate description of what this model is. And ultimately, that is why it's larger. If we take more points and we add them together, that is why we will get a bigger number. Hope you enjoyed. Stay safe and peace.